Okay, 6th grade, we're going to talk about Unit 8, Lesson 11, but we're going to start on Lesson 10 because there's some information on here that you have to, well, not necessarily have to see, but we want you to look at. So we're looking at a data set right here, talking about how long it takes Diego to walk to school in minutes over a 5-day period. It was 12 minutes, 7 minutes, 13 minutes, 9 minutes, 14 minutes. I already told you that the mean is 11. So I'm going to do a dot plot right here. And let's see, 7, 7, 8, 9, got 10 right there, 11, 12, 13, 14. So right here, they're asking you to put a triangle where the mean is. So the mean again was 11. So at the 11, there would be a triangle. And then putting a dot on all of these, 12, 7, 13, 9, and 14. Okay, so using mean can be a measure of center, meaning it's the balancing point in a data set. It's the middle thing. So not quite like the median, but it's the average. And we'll get to median also. So what we want to look at is the deviation from the mean. Deviation means kind of like the distance from it, almost like absolute value, but absolute value is distance from zero. The deviation, we're talking about distance from the mean. So here, 12 minutes is 1 minute from 11. So if you were talking about the average, it's just a little bit, talking about that it takes 11 minutes, say, well, it took you 1 minute longer. That's one way of looking at it, deviation. The time you walk 7 minutes, well, that's 4 minutes away from the mean. There's no positive or negative on the deviation. It's just how far. So you would say that he was 4 minutes faster on this day than what he averaged. And by the way, left or right of it, this isn't all that important, but we'll go ahead and put that in that is right of it. This is the left on the number line. 13 minutes has a deviation of 2 minutes from 11, and 9 has a deviation of 2 minutes from the 11. Oh, sorry, we're missing one. And then 14 is a deviation of 3. Okay, so that's going to matter for when we get to lesson 11. Scooch on over to that right here. So lesson 11 is talking about the deviation from the mean, which is what we touched on over there, but we're going to get into it more here. So there's something that you're going to know or learn called MAD. MAD is the mean absolute deviation. So the mean absolute deviation means we're looking at all the distances, how far each data point is from the mean. So on that last one where we had, it was 1 spot or 2 or 4, or I don't remember what the other numbers were, but those were all the deviation. So what you're going to do, or the absolute deviation. So what you're going to do on these is you're going to find out how far everything is away from it, and then find the mean from it, the average of it. So what's the point of mean absolute deviation? Mean absolute deviation is what we will call a measure, or what we call a measure of variability, or a measure of spread. Meaning the smaller that deviation is, that mean absolute deviation is, the closer the numbers are together, the more compact the spread is. The larger the mean absolute deviation is, so if you have a mean absolute deviation, let's say that his average time walking, a good one to do is like tests. So let's say you have an average of a 75% on your test scores, and your mean absolute deviation is 20 points. Well, that means your numbers are spread all over the place on your test. You probably have a 35 on there, you have some 100s on there, some high 90s, some 40s. Your numbers are everywhere. But if someone has, say, an average of 90%, and their mean absolute deviation, their MAD, is 5, that means most of their scores are close to each other. So if we were to take the average age of a student in room 17, Mrs. Pyrock's room, their mean absolute deviation would be very small, because everyone in that classroom is probably 12 or 13. Maybe there's an 11-year-old in. our mean absolute deviation should be a little bit larger in room 20 because we have some 5th graders in. Okay, so we're going to go over how to do this. I'm going to do that warm up. We're going to look at this. So, for example, if I was to talk about the mean absolute deviation, I can already tell you that the mean absolute deviation is going to be the largest for this one, because see how spread out these numbers are? It goes from 1 to 9 and they're all over the place. It's going to be a little bit smaller for this, and then it's going to be the smallest for this one because these are so compact. And sometimes, for example, if I'm looking for, we used to be able to run reports for some of our data, and I'd want to have a small mean absolute deviation for test scores that students had. That means everyone's fairly close. If everyone's way all over the place, that's not great news. So, by the way, this is, so let's say that I was choosing for a basketball team and these stats were given to me. And it's the number of baskets Elena made in a game. And one day she had 1, 2, couple of games she had 3, 4, couple 5, 6, couple had 7, 8, 9. And you had Jada was from 2 to 8, and Lynn was anywhere from 3 to 7. That's telling me Elena, I'm not really sure what I'm going to get from her. Some days she can have a really bad game. Some days she has really good games. You don't really know. Lynn, you kind of have an idea, a lot better idea of what you're going to get from her. She's fairly consistent. That's enough. Okay, so moving down, we're going to look at this information right here. Blah, 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 blah. Record the distance between. Okay, so it says, recall that the mean of Elena's data as well as that of Jada's and Lynn's data was 5. So all of them had the same mean. They all averaged 5. So what we want to do is find the distance from 5 for each of these. So they did 2 of them for you. That 4 baskets made was 1 away from 5. 6 baskets made was 1 away from 5. 5, that's 0 away. 1 is 4 away because 5 minus 1 is 4. 9 is also 4 away because 9 minus 5 is 4. This is 2 away. 3, 3, 2, 2, 0, 2. So then what you're going to do to find the mean absolute deviation is now you're going to take all of these numbers, how far all of these numbers are away from the mean of 5, and you're going to add them together. I'm not going to put addition signs on all of them. We'll just add it. 1 plus 0, 1, 5, 6, 10, 12, 15, 18, 20, 22, 24. Your mean absolute deviation is not 24 because you have to divide it just like you do mean by how many data points there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So divided by 12 gives you a mean absolute deviation of 2. Meaning the average distance away from her mean of 5 is 2 baskets. I think that's baskets, right? Okay, so we're going to go to Jada and look at mean absolute deviation here. Again, the mean was still 5. And so distance from 5. So 2 is 3 spots away. This is 1, 0, 1, 1, 1, 1, 2, 2, 1, 3, 2. We're going to add these together. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 18. So the average distance away is, the total deviation is 18, but we have to divide it by the number of data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's going to give you 1 and 5/10. So that means Jada is more consistent than Elena. And then last one, Lynn. And distance from 5 again, because the mean was 5, is 2, 1, 1, 1, 0, 0, 2, 0, 1, 1, 1, 2. So we're going to add all these together. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divide that by the 12. Our mean absolute deviation is 1. So remember when we went back up at the top, when we talked about the dot plots, and I told you that Elena was going to have the largest mean absolute deviation because their numbers were spread out. Jada's was going to be a little less, and then Lynn would be the closest. And you can see it right here again. This was the mean absolute deviation of 2, 1.5, and 1. This is just showing more consistency that the spread is closer together, okay? Close to the center. And that's how you do that. Let me go down to the practice problems if I can actually find them. Excuse me. Okay, problem 1, Han recorded the number of pages that he read each day for 5 days. The dot plot shows his data. So we have C2, a difference of 2, and there's 2 spots. That means that's 25. Right, 25, 28, 32, 36, 42. I guess they're all written right here. So we have to find the mean first. How do you find the mean? You're going to add all of the numbers together and divide by what? Yes, you're going to divide by 5 because there are 5 data points on here. So it'd be 25 plus 28 is 53 plus 32. 53 plus 32 is 85. 85, that's 121, 163. Oops. 163, and we'd have to divide that by 5. That's going to give us 32 and 6/10. So the distance from the mean, this is where people are going to, see if I can show you on here. Keeping in mind, when I do these, if you're using a calculator, which again, I don't totally care. Hold on. Let me make sure I added that up correctly first, because that'd be kind of embarrassing. Okay, good. Ooh. Stop it. Okay. When you're using the calculator, just be careful. But these are fairly easy. You can just type in the mean, which was 32 and 6/10, and just always hit, I'm subtracting the 25 away. It's a distance of 7 and 6/10. So I'm going to put that, the distance from the mean right here is 7 and 6/10. And even if you have a number that is larger than it, I still put in the mean first. The mean being 32 and 6/10, right? Okay. 32 and 6/10. And then I am going to still put, I'm going to subtract, let's say we're going to do the 36. Even though that's a negative number, I know that that's how far away it is. I'm not going to put the negative, just means this is 3 and 4/10 away from it. And I can prove that by just taking 3 and 4/10. Oh, goodness gracious. 3 and 4/10 and add it. I hope that was the addition button to 32 and 6/10 to get 36. Ooh, that's hard to do backwards. Okay, so anyway, I'm going to still do these other ones. So this is going to be 4 and 6/10. Right, 32. We can go back. Okay, I forgot. Okay, I need to write this down over here. 32 6. So this is only 6/10 away, and this is going to be 9 and 4/10 away. Okay, so then to find the mean absolute deviation, I'm going to add all of these up. And as I said, use a calculator. If I'm looking at this and I'm guessing that's 11, 12, 15, I should be somewhere around 25. So 7 and 6/10 plus 4 and 6/10 plus 6/10 plus 3 and 4/10 plus 9 and 4/10 gives me a total of 25 and 6/10. Is that my mean absolute deviation? No, that's my absolute deviation. I need to divide it. I need to find the mean of that and divide it by 5. It gives me a mean absolute deviation of 5 and 1200. Goodness. 5 and 1200. So, oops. 5 and 12. Okay. If you have any questions, we're going to go over this on Zoom anyway, but if you have any questions, let me know. And